So in this video we will be discussing on the design of a circular tank with flexible base. Let us take this particular problem. Design a circular tank with flexible base for a capacity of 400,000 liters. The depth of water is to be 4 meter, including a freeboard of 200 mm. Use M20 concrete and mild steel reinforcement. Okay, so our tank is a circular tank, and the wall of the tank and floor is connected by a flexible joint. This we have seen in the previous video. This is the wall, this is the floor. It is joined by a flexible joint and movement is possible. So the deflected shape of this particular wall will be A, B1, D, and the pressure distribution is shown. Hydrostatic pressure distribution is also shown. Okay, so the first step is to find out the dimension of tank. We know the effective depth of water from capacity point of view. That means in the question it is given 4 meter depth, including a freeboard of 200 mm. So in effective, the water depth will be only 3.8 meter. The 200 mm is freeboard. Okay, so the effective depth in our case become 3.8 meter, and if D is the inside diameter of tank, then we know that pi d squared by 4 into 3.8 should give 400. What is 400? Because it is given 400,000 liters. We know that in 1 meter cube, 1000 liter of water can be there. So it is 400 meter cube, and from that we can find out D is equal to 11.6 meter. In step 2, is the design of section. So here we find out what is the depth. It's already given. We found out the diameter. So that geometry is over. Then we have to find out the section. Section means the wall thickness, the AST, like that. Okay. So in the step 2, we take W, the specific weight of water, as 9,800 Newton per meter cube. We know the weight density of water is 1 gram per cc, and from that we can calculate it out 9,800 Newton per meter cube. The thickness of the wall is found out by using an empirical relation. T is equal to 3h plus 5, that is in centimeter. So we are getting 170 mm. Okay, so we found out the thickness of the tank also. Then what is remaining? We have to find out the reinforcement. In this particular case, there is no bending occurring in this particular in the walls. There is only hoop tension. So the maximum hoop tension will occur at the base, because the maximum pressure will be at the base. Okay, that we have discussed in the previous video. So the maximum hoop tension is given by this formula WH into D by 2. Substituting the values, we are getting 227360 Newton per meter height. Okay, per meter height at base. From table 4 IS 3370 part 2, we know the permissible stress in steel, and that is given as 150 Newton per mm squared for mild steel reinforcement. Okay, so by using the formula ASH is equal to this hoop tension divided by sigma ST. We know that tension is a force, and divided by sigma ST. The tension unit of tension is Newton. This is Newton per mm square. So if I am dividing this by this, we will get AST. Okay, so this is the case of direct tension, the hoop tension. So we are getting 1977 mm squared per meter height. That is the area of the hoop reinforcement. So assuming 20 mm dia bars, the area of one bar become 314 mm squared, and the spacing of the hoop, we know that area of one bar divided by area, the total area. Thereby we are getting 158 mm. Hence provide 20 mm dia bars at 150 mm center to center as hoops or hoop reinforcement. So what the spacing that we got is 158 mm and what we provided is 150 mm. So definitely the area provided will be greater than the area required. We also found out the area provided just because by using this formula itself. Okay. From this formula, if I know the area 1 bar and the spacing provided, then I can find out the total area, right? Therefore, area 1 bar is 314 divided by 150 is the spacing provided into 1000 will give you 2093 mm square. Then we have to, so after this one we decide, we had given the particular, we found out the section thickness, the wall thickness, we found out the hoop reinforcement. Then we have to check whether the wall thickness which was found through the empirical formula is correct or not. So the checking the wall thickness provided. So that is the first check. So that can be checked by checking the permissible stress in direct tension in concrete, whether the permissible stress in concrete is exceeded or not. If it is exceeded, then we have to redesign, because this is according to the no cracking condition, resistance to cracking condition, which is given in IS 3370 part 2. Okay, table 1. In table 1 it is starting from M25, but for this particular thing, this is also given in 1967 published, so it is taken as 1.2. Okay, the permissible stress in direct tension, this is again we know the stress is nothing but, what is stress? Stress is nothing but force by area. Here in this case it is force. The force means your hoop tension. Here the force is nothing but the hoop tension, and area is nothing but the equivalent area. This equivalent area also we have discussed in the previous video. So substituting the hoop tension, we know the maximum value is WHD by 2, and the hoop tension, the equivalent area is nothing but A plus M minus 1 into ASH, or here it is ASH, and otherwise we have studied AST. Okay, so A is nothing but the total area and ASH is the area hoop reinforcement. So substituting the value, we are getting 1.16 is less than or equal to 1.2, hence the section thickness that we have provided is safe. Okay, so the second check is the check for minimum reinforcement. What is the check for minimum reinforcement? So as per clause 8.1.1 of IS 3370 part 2, there it is given the minimum reinforcement is 0.4% of the cross-sectional area, and this we have seen through the previous video how it is coming. You can always refer to part 2 3370. Okay, so it is a 0.4 divided by 100 into 1000 into 170 the cross-sectional area, and what we are getting is 680 mm square. So the AS, which is less than the ASH provided, ASH provided is around 2093, and here we are getting only to 680 mm square, hence it is safe. Okay, the third check that we have to do is the spacing of the hoops. This also we have discussed previously in the previous video. It is given in IS 3370 part 2 clause 8.1.1. The spacing should not exceed 300 mm or the thickness that we have given. Here the thickness is 170 mm. So what we have provided is 20 mm at a 150 mm center to center, and it is safe. So although the spacing of hoop reinforcement can be increased towards the top of the wall section, because towards the top the hoop tension will be very minimal, so we can increase the spacing of this hoop reinforcement, but as the thickness is 170 and what we have provided is 150, so we are not changing the reinforcement spacing, keeping the reinforcement dia as 20 mm. But I can always reduce the diameter and keep the spacing limit to 170 mm for an economical design, which I am not doing in this particular example. Okay. So So the step 3, what is remaining is the vertical reinforcement. So what we have designed is, we designed through the step 2, we designed the section thickness. We found out the section thickness. We found out the hoop reinforcement, that is 20 mm dia at 150 mm center to center, and what is remaining is only the vertical reinforcement, right? So the vertical reinforcement we can find out by using the percentage of reinforcement as same as 0.4%, the minimum percentage, and it is 680 mm squared. Okay, providing 10 mm dia bars, the spacing that I am getting is 115 mm, hence I am providing 10 mm dia bars at 110 mm center to center in the vertical direction. So this is the reinforcement, 10 mm dia bars, which is provided at 110 mm center to center in the vertical direction. Okay, so that is the distribution reinforcement. Then what is remaining is the tank floor. Since the tank floor is resting on the ground, and we are providing a nominal thickness of 150 mm, and the minimum reinforcement percentage is 600 mm square. So as per clause 8.1.1, as that thickness is less than 300 mm, we can provide it as a single layer of reinforcement in one layer. So what if I am taking as 10 mm dia bars, then I can find out that by providing 10 mm at 130 mm center to center, both ways will actually match with the minimum AST that is written. Okay, so this is the section detail. You can see the floor slab, which is 150 mm, and the reinforcement is 10 mm at 130 mm center to center. Below that there is a PCC layer of lean concrete M10X, and suppose we are giving a 75 mm or a 10 or 100 mm you can provide. Here it is a flexible joint. In the IS 3370 part 1, you can see all the details regarding the joints, and here you have to provide joint sealing compounds, strip painting, and there is a flexible layer over here. The hoop reinforcement we have calculated is 20 mm at 150 mm center to center, or 15 centimeter center to center, and the vertical reinforcement is 10 mm dia at 110 mm center to center, and the thickness we found out as 170 mm. Okay, thank you.